I want you to picture this. You are stuck in bumper-to-bumper traffic. It's 5 p.m. on a Tuesday. The radio is playing the same 3 songs you've heard 1,000 times. Your foot is tired on the brake and your mind starts to wander. You're bored, so you start looking around the car. You look up at the edge of your windshield, and you see them. Those mysterious black dots on the glass. That solid black band running around the perimeter of the glass that slowly dissolves into a pattern of smaller and smaller black dots. You've seen them your entire life. Every car you've ever been in has them. Maybe you thought they were a built-in sun visor. Maybe you thought they were just a decoration to make the car look sleek. Or maybe, like most people, you just stopped noticing them altogether. It seems like a weird design choice, right? Why put permanent dirt on a window that is supposed to be perfectly clear? Why block your vision with black paint? Is it just aesthetic? Is it a conspiracy to make the viewing area smaller? But here's the surprising truth. If those dots weren't there, your windshield would fall out, literally. Without that black paint, in a serious crash, the glass would detach from the frame, the roof might collapse, and your airbag would be completely useless. Today, we're uncovering the mystery of the frit, how it battles the power of the sun, and why it is the unsung hero of automotive safety. To understand these black dots, we first have to look at the dark ages of car manufacturing. We have to go back to a time when cars were heavy, inefficient, and covered in chrome. Go back to the 1950s and 60s. Look at the windshield of a classic Chevy Bel Air or a Ford Mustang. You won't see black dots. Instead, you see huge, shiny metal chrome trim. Back then, we didn't glue windshields in place. We used mechanical gaskets. It was basically a thick rubber seal squeezed between the metal car frame and the glass. It was heavy, it was expensive to manufacture, and honestly, it was terrible. If you hit a big bump, the glass could rattle in the frame. If it rained, they leaked constantly. And worse, that metal trim trapped water against the frame, causing the car to rust from the inside out. But then everything changed. The oil crisis hit. Cars needed to get lighter, faster, and more aerodynamic. Manufacturers needed a way to seal the glass directly to the metal body to reduce drag. They needed glue. But there was a massive problem. Glass is slippery, and industrial glue is ugly. If you just smeared glue on a clear window, you'd see the messy, uneven goop from the outside. It would look cheap. They needed a way to hide the mess, and more importantly, make it stick forever. This brings us to the frit. That's the technical name for that black ceramic paint. And let's be clear, it's not just paint. You can't scrape it off with a razor blade. It is a ceramic enamel that is screen printed onto the glass and then baked in a furnace at over 1200 degrees Fahrenheit. It fuses with the glass. This baked-in ceramic band solves 3 massive engineering problems. Problem number 1 is the sunblock factor. Modern cars use a super strong adhesive called urethane to bond the glass to the frame. It's incredibly tough, but it has one fatal weakness: ultraviolet light. Think of it like an old plastic lawn chair left in the backyard. After a summer in the sun, it gets chalky, brittle, and eventually snaps when you sit on it. UV rays cook plastic and glue. If sunlight hits the urethane glue holding your windshield, the glue degrades. It loses its grip. Eventually, your windshield would literally unstick itself. The solid black band is essentially SPF 5000 for the glue. It stops the UV rays so the bond stays permanent. Problem number 2 is the grip. Have you ever tried to paint a glossy tile wall or a mirror? The paint just peels right off, right? Glass is too smooth. Industrial glue struggles to grab onto a perfectly slick surface. The frit isn't just for looks. Because it's baked on ceramic, it's rough. It acts like sandpaper. It provides a rough, gritty surface for the adhesive to bite into. Without the frit, the glue would just stick to itself, not the window. But that explains the black line. What about the dots? That leads to problem number 3, the oven effect. Physics 101, black absorbs heat. Clear glass lets it pass through. When your car sits in the baking sun, that black band gets scorching hot, much hotter than the clear glass right next to it. If you had a hard line between the boiling hot black paint and the cool clear glass, the temperature difference would create thermal lensing. The glass would distort optically. It would look like you're looking through a funhouse mirror at the edges, or worse, the stress would snap the glass. The dots create a thermal gradient. They spread the heat out gradually, smoothing the transition from hot to cool so the glass expands evenly and doesn't warp or shatter. It's a heat sink for your window. Now here's the scary money and law angle. Why do car companies spend millions baking these dots onto every single car? Because the windshield is a structural part of the car's safety cage. In a modern car, the glass provides up to 30% of the roof's structural strength. When your passenger airbag deploys, it shoots out at 200 miles per hour. It doesn't hit the passenger first, it hits the windshield and then bounces back to catch your face. If the windshield pops out because the glue failed or the UV light destroyed it, the airbag has nothing to push against. It flies out the window and you hit the dashboard. The frit is the anchor that saves your life. But recently, the frit has taken on a new job. Look at the top center of your windshield, right behind the rearview mirror. You'll see a massive patch of black dots, sometimes dropping down low. This is the third visor. It blocks the sun in that annoying gap between your driver and passenger sun visors. But more importantly, it's camouflage for the car's eyes. Modern cars are covered in rain sensors, lane departure cameras, and lasers. They are ugly boxes of electronics with wires hanging out. Car designers hide them behind the frit. They leave tiny clear windows, called apertures, in the black ceramic paint for the camera lenses to peek through. The frit hides the wiring and the messy glue, making your high-tech robot car look sleek and clean. It's wild to think about. A simple band of ceramic paint, it holds the roof up in a rollover. It stops the sun from destroying the glue. It prevents thermal shattering. And it hides the cameras that keep you in your lane. Without the frit, modern car design, the safety, the shape, the technology, simply wouldn't exist. We'd still be driving heavy steel boxes with leaky windows. So, the next time you're stuck in traffic, staring blankly at those little fading dots, don't just see them as decoration. Give them a little nod of respect. They're doing a lot of heavy lifting. If this video changed the way you see your car, hit that like button and subscribe for more hidden stories behind the everyday things you take for granted. And let me know in the comments, did you know about the third visor trick?